The project is named MEMENTO. It stands for Multi-Camera High Frame Rate Synchronization. It relates to developing a system of cameras whereby they can record high frame rate footage in very accurate time synchrony between a number of cameras. The project also involves the development of the camera technology itself, and there were a number of technologies that went into this camera involving high performance image sensors, high performance data transfer, and sensor cooling technologies and other data transfer techniques.
So basically this project was done in a collaboration between the University of Malta and MCST Audiovisual Limited. The University of Malta was primarily involved with the experimental part, right, with the research part, whereby we got to experiment new technologies and the main idea behind also the camera, where there are not one patent but also other patents involved. On the other hand, MCST Audiovisual Limited was more involved in the aspect of the development part and the commercialization part, whereby they included industrial workflows. They also got people from the industry to help with this project, and they got those experimental ideas that we got from university and turned them into an actual product that can be used by producers elsewhere.
So the two markets the camera is designed to cater for are the scientific market and the broadcast market. When you're designing a camera, a high-speed camera such as this one, the headline specification is that of frame rate. Primarily, we tried to achieve the best possible performance we could with off-the-shelf image sensors which were available to us. The camera can handle images and video footage of resolutions in the full HD range at frame rates exceeding 3000 frames per second. The camera includes a number of outputs which can output the video footage in real time so that it can be fed into a concentrator together with footage being recorded from a number of different cameras. It also includes the possibility of recording within the camera using an SSD drive. It includes features such as, for example, touchscreen interface as well as a V-mount battery, and the lens mount is also a standard lens mount that is used in the broadcast sector.
There were quite a lot of challenges that we encountered during the project, but I would majorly categorize them into three. The first one was that before we embarked on this project, there wasn't really much of an infrastructure in the country with respect to complex electronic product development. That means people who are experts in the area of developing products, and apart from that also the collaboration between companies who actually went through this process before. That was the first challenge. The second challenge would be that we were newcomers to this area. That also means that we were quite green and we had quite a steep learning curve to get where we are now. But thankfully, we managed to get a product and we also learned a lot from that process. So now we're much more confident to issue not just this, but also other products in the future. And thirdly, the third category would be the technical challenges that we encountered. The first one was that given that we are electronics engineers as well, there was a bandwidth limitation with respect to cameras out there in the market. So the first thing that we needed to solve was that we had to take the current generation of electronics to the extreme and push the boundaries of performance with respect to image technology and product of the sort. And the second one was with regards to cooling. So yes, we've pushed the performance to the limit, but at the same time, our electronics were heating up much more than we expected. So we had to find another solution to cool down the electronics, ideally to sub-zero temperatures.
MEMENTO project was funded through Fusion R&I funding scheme as offered by MCST. The specific need to apply for this funding was particularly to commercialize and further refine the design to increase the technology readiness level of the previous work carried out and make it more market-ready design. So the funding enabled the design, development and prototyping of multiple iterations of the work which was carried out. Without MCST funding, the alternative would have been to seek private investment. The disadvantage would be that the process may have been lengthier in order to find the right people to invest, and also we may have not been able to secure the required funds which we needed to complete this project.